50 years ago, humanity left its mark on another world for the very first time. Yes, I'm talking about the historic moon landing. It wasn't just a milestone, it was a triumph of courage, science, and determination. In Neil Armstrong's iconic words, it was a giant leap for mankind. And it truly was, a moment that changed our perception of what we could achieve. But we didn't stop there. Since then, we've accomplished even more daring feats. We've sent probes and rovers and even helicopters to Mars. We ventured into the vastness of the solar system, visiting Jupiter and Saturn, capturing the first close-up images of Pluto, and even sending spacecraft beyond the edges of our solar system into the uncharted depths of interstellar space. Yet, despite all this progress, there's one thing we haven't done: send humans beyond the moon. The farthest we've traveled is still that iconic lunar surface. But now, all of that is about to change. You've probably guessed it by now. We're talking about sending humans to Mars. I know it sounds like something straight out of science fiction. For decades we've heard the talks, seen the concepts, and dreamed of the day. But nothing ever seemed to happen. It felt like a goal that was always just out of reach. But not anymore. And no, this isn't some random science fiction fantasy. This is real. The plans are in motion, and humanity is finally gearing up for the most daring mission in history. Now, I'm not saying it will happen tomorrow or even next year, but it's no longer a distant dream. The groundwork has been laid, and it's coming together faster than ever. NASA, SpaceX, ISRO, ESA, China, and other space agencies are working on a unified plan to achieve this monumental feat. The vision is clear, and the work is already in motion. In this video, I'll take you on an incredible journey as we uncover how humanity is planning its most ambitious mission yet: sending humans to Mars. From the meticulous preparations on Earth to building a lunar base, from launching astronauts to the moon to the final, daring voyage to the Red Planet. Welcome back to Mind Meld. This is the story of how we're preparing for the next giant leap for mankind. The moon was humanity's first step into the cosmos, but it's far from the last. Today, the focus has shifted to a destination that once felt unreachable: Mars. The dream of setting foot on the Red Planet is no longer just an idea, it's a reality taking shape. So why we haven't dared to send human to Mars yet? The answer lies in the immense challenges it presents. The sheer distance alone, over 200 million kilometers, makes every aspect of the journey more complex. How do we protect astronauts from deadly cosmic radiation? How do we ensure they have enough food, water, and air for a mission lasting years? And even if we get there, how do we land safely and survive on a planet with thin air, freezing temperatures, and no breathable atmosphere? These challenges have kept Mars just out of reach, until now. Thanks to decades of innovation, we finally have the tools, the knowledge, and the determination to make this mission possible. But this journey won't start with Mars. It begins right here on Earth, and our first stop is much closer: the Moon. Before humanity can take its first steps on Mars, we need to perfect the tools, systems, and methods to get us there and back safely. And that preparation is in motion right now here on Earth as we speak. So what exactly are we doing to turn this mission from science fiction into reality? Let's dive into the specifics. First, the spacecraft. We're not building a single rocket to Mars. We're designing an interconnected system. NASA's Space Launch System, SLS, will play a critical role in launching heavy payloads, including the Orion spacecraft, which will ferry astronauts to the moon and potentially act as a transfer vehicle for the Mars mission. Don't worry. We will discuss in details why transfer vehicle and how it will work later in this video. On the other hand, the game changer, SpaceX's Starship rocket, will bring its fully reusable design to initiate the very first step of our journey, launching astronauts from Earth towards the moon. Starship is designed to launch from Earth, refuel in orbit, and carry astronauts to Mars via the moon, or even deliver cargo directly to Mars. Starship is also built with a stainless steel hull to withstand the extremes of deep space, and its methane-based Raptor engines can potentially be refueled on Mars using in-situ resource utilization, More on that later. Next step is a very well-known stage which we usually take for granted, the astronaut training. But this time it's not the usual training routines. Mars isn't a year-end trip to the ISS or even the Moon. It's a multi-year mission. That means the crew needs to be prepared for every possible scenario, from medical emergencies to mechanical failures. Training simulations are being conducted in Mars-like analogs, such as the High Seas Habitat in Hawaii and the Mars Desert Research Station in Utah. These training programs cover more than just survival. Astronauts are practicing geological sampling, habitat maintenance, and even psychological adaptation to isolation. This isn't just a NASA or SpaceX effort. Agencies worldwide are contributing. ESA is developing systems like the Mars Sample Return mission, which lays groundwork for automated logistics. Meanwhile, ISRO and China's CNSA are advancing autonomous robotics and long-duration habitat technologies. Together, these components form a truly international blueprint for Mars exploration. And don't worry, we will explore each and every bit of this plan, so buckle up. We will now dive into the most exciting part. We will explain the overall mission plan, and then we'll take you through each and every part of it, one by one. So far, you either already know that we will be using Moon as the pitch stop, or you're wondering why Moon when we are talking about going to Mars. To understand why the Moon is a critical part of our journey to Mars, let's first take a step back and look at the bigger picture of how this mission will unfold. Sending humans to Mars isn't just about one rocket. It's a carefully coordinated series of missions, each with a specific purpose. The first stage involves sending cargo to Mars. These won't just be one or two rockets, but a fleet of multiple spacecraft, launched in advance to prepare the surface for human arrival. Each rocket will carry essential supplies, habitat modules, power systems like solar arrays, and life support infrastructure. There will also be cargo dedicated to producing resources on Mars itself, such as oxygen and fuel, using technologies like MOXIE and Sabatier reactors. These cargo missions will launch months, if not years, before the astronauts even leave Earth. The idea is to have everything in place and tested remotely by the time humans arrive. Once the cargo safely lands on Mars, the next phase begins, sending humans. The human journey starts with a launch from Earth to the Moon, using spacecraft like NASA's Orion or SpaceX's Starship. The trip to the Moon takes about 3 days. Once there, astronauts will spend weeks, possibly months, at the lunar base. Why? To prepare. This involves assembling the Mars-bound spacecraft, refueling it, and conducting final training in a low-gravity environment. After the preparations are complete, the crew will embark on their journey to Mars. The trip itself will take around 6 to 9 months, depending on the alignment of Earth and Mars. Once they arrive, the astronauts will stay on Mars for about 30 days during the initial missions, with future missions extending this duration as we establish a more permanent presence. After completing their mission, the crew will use the same spacecraft or a specialized transfer vehicle waiting in orbit to return to Earth. Now, let's come back to the question, why stop at the Moon? Why not just go directly to Mars? It's a valid question. The short answer is efficiency and safety. Launching directly to Mars from Earth comes with significant challenges. First, the sheer amount of fuel required to carry heavy cargo and a crew to Mars in one go is enormous. Earth's gravity is a formidable obstacle. By using the Moon as a staging ground, we can take advantage of its weaker gravity, allowing us to launch heavier payloads with much less fuel. Second, the Moon offers a unique testing environment. Its harsh surface conditions, extreme temperatures, radiation, and dust are similar to those on Mars. This makes it the perfect place to test technologies, practice long-term survival, and refine our systems before committing to the full Mars mission. Third, the Moon has resources we can use. For example, the water ice found at its poles can be mined and converted into hydrogen and oxygen for rocket fuel. This concept, known as in-situ resource utilization, reduces our dependence on Earth for supplies, making the mission more sustainable. This is where NASA's Artemis program comes into play. Artemis isn't just about returning to the Moon. It's about building a long-term presence there. The program plans to establish a lunar base camp and an orbiting space station called the Lunar Gateway. The Gateway will serve as a hub for astronauts traveling between Earth, the Moon, and eventually Mars. It will provide living quarters, science labs, and a docking station for spacecraft. The Artemis program will also focus on mining lunar ice, testing habitat modules, and assembling the transfer vehicle that will take humans to Mars. While the Moon might seem like just a pit stop, it's actually a crucial part of the mission. It's where we'll fine-tune the systems and strategies that will ensure the success of the Mars mission. And don't worry, we'll dive deeper into the Artemis program and the Moon base plan in a later video. With the Moon as our launch pad, we're laying the groundwork for an ambitious, sustainable journey to Mars. Next, we'll explore the details of how astronauts will travel from Earth to the Moon, what they'll do during their time there, and how it all leads to the ultimate voyage to the Red Planet. To kick off the mission, we first need to launch astronauts and critical equipment from Earth to the Moon, setting the stage for the next phase of the journey. NASA's Space Launch System, or SLS, will play a central role in this phase. This massive rocket, standing over 100 meters tall, is one of the most powerful ever built. It's designed to launch heavy payloads, including the Orion spacecraft, which will carry astronauts to the Moon. But NASA isn't the only player here. SpaceX's Starship is also being developed as part of the Artemis program. Starship will work in tandem with SLS, serving as the lander that ferries astronauts from lunar orbit to the Moon's surface and back to the Lunar Gateway. Starship's fully reusable design and massive payload capacity make it an essential piece of the puzzle. Once launched, it takes about 3 days to reach the Moon. During this time, the Orion spacecraft performs a series of precise trajectory corrections to ensure it enters the Moon's orbit at the right angle and speed. Orion's service module, developed by the European Space Agency, provides power, propulsion, and life support during this phase. The crew on board will use this time to conduct system checks, prepare for lunar orbit insertion, and stay in constant communication with mission control. While the spacecraft handles most of the journey autonomously, astronauts are always ready to step in if something goes wrong. As Orion approaches the Moon, it executes a critical maneuver called lunar orbit insertion, the journey to Mars. Now that we've arrived at the Moon, it's time to dive into what happens next. The Moon base isn't just a pit stop. It's the workshop where the Mars mission truly comes to life. Here, astronauts and engineers will focus on perfecting the systems and technologies needed for the journey ahead. The primary goal at the Moon base is preparation. This includes assembling the Mars-bound spacecraft, testing life support systems, and refining techniques for in-situ resource utilization, or ISRU. Astronauts will also practice long-duration survival in a low-gravity, high-radiation environment, simulating the challenges they'll face on Mars. The Lunar Gateway, orbiting the Moon, acts as the link between Earth and the Moon base. It will be used to transfer cargo, refuel spacecraft, and act as the departure point for the Mars mission. It's a critical hub that ensures everything is ready for the next giant leap. With the Moon base operational and the Mars-bound spacecraft assembled and fueled, we're now ready for the next phase, the journey to Mars itself. With everything prepared at the Moon base, the crew is now ready to embark on the most ambitious leg of the mission, the journey to Mars. This isn't just a short hop across space, it's a 6 to 9 month voyage covering over 200 million kilometers through the vast emptiness of deep space. Every moment of this journey will test the limits of our technology, ingenuity, and human endurance. The journey begins with the Mars-bound spacecraft, likely assembled and fueled at the Moon base or in lunar orbit. SpaceX's Starship, or a specialized transfer vehicle, will carry the crew and all the essentials for the mission. The spacecraft is designed to handle deep space challenges, equipped with advanced radiation shielding, artificial gravity systems, and life support systems that recycle water, air, and waste to sustain the astronauts. For the crew, life aboard the spacecraft will be anything but ordinary. With no gravity to anchor them, astronauts will rely on exercise equipment to maintain muscle and bone strength. Meals will consist of pre-packaged food, supplemented by plants grown in small hydroponic systems on board. Every resource, oxygen, water, and even energy will be carefully monitored and recycled to ensure nothing is wasted. Communication with Earth will also be a challenge. With signals taking up to 20 minutes each way, astronauts must be largely self-reliant, handling technical issues and emergencies without immediate help. Psychological health will also be a priority, with the crew living in close quarters for months, millions of kilometers away from home. The journey comes with its fair share of risks. Cosmic radiation and solar storms pose constant threats despite the spacecraft's shielding. Microgravity can lead to health issues like muscle atrophy and fluid redistribution in the body. To counter this, the crew will follow a strict regimen of exercises and health monitoring. There's also the monotony of the long voyage, a test of mental strength and teamwork. Crew members will rotate duties from spacecraft maintenance to scientific experiments to keep both the mission and their minds on track. As the spacecraft approaches Mars, the tension builds. A critical maneuver called Mars orbit insertion will slow the spacecraft enough to be captured by the planet's gravity. This step is crucial. Get it wrong, and the spacecraft could miss Mars entirely or crash into its surface. This level of precision is crucial. There's no room for error. As the landing begins, the crew braces for the most intense phase of the journey. The heat shield absorbs blistering temperatures as the spacecraft tears through the atmosphere at hypersonic speeds. At a critical altitude, the parachutes deploy, slowing the vehicle significantly. In the final moments, the retro-propulsion system fires up, allowing the spacecraft to hover briefly before touching down gently on the Martian surface. This nail-biting sequence happens in just minutes, and for the crew, it's a surreal moment. As the dust settles, they realize they've done it. They've landed on Mars. The landing site is a carefully chosen area, prepped well in advance by robotic missions. Supplies, habitat modules, and life support systems have already been delivered, waiting for human arrival. As the crew steps onto the surface, they will immediately begin securing their resources, conducting system checks, and establishing a base of operations. This is a crucial phase. Ensuring that everything is operational sets the tone for the mission's success. The crew will spend the first few hours confirming that their habitats, power systems, and communication links are all functioning as planned. This isn't just a technical achievement, it's a moment that will define human history. As the crew takes their first steps on Mars, they're doing more than just exploring a new world. They're opening the door to a future where humanity thrives on multiple planets. Next, we'll dive into what happens after those first steps. How will the crew establish a foothold on Mars? And what's the long-term plan for survival and exploration on the Red Planet? Let's find out. The spacecraft door opens, and for the first time in history, humans step onto the surface of Mars. The crew descends carefully, their boots sinking slightly into the rusty soil. It's a moment that will echo through time, a triumph of human determination and ingenuity. But for the astronauts, there's little time to soak it all in. The real work begins now. The pre-delivered cargo, sent months or years ahead of the crew, contains essentials like habitat units, power systems, and rovers. Once everything checks out, the crew begins setting up their living and working spaces. The inflatable habitats are expanded, providing a safe environment with regulated oxygen, temperature, and radiation shielding. Solar panels are deployed and connected to battery systems, ensuring a steady power supply for the mission. The crew's initial stay on Mars will be brief, about 30 days for the first mission. During this time, they'll focus on two main goals: survival and exploration. The astronauts will live inside modular habitats, which include sleeping quarters, a small lab, and a communal area. Food will consist of pre-packaged supplies supplemented by fresh produce grown in compact hydroponic systems. Yes, they're farming on Mars from day one. Waste will be recycled using advanced systems that reclaim water and other resources, ensuring nothing goes to waste. Equipped with rovers and tools, the crew will explore the surrounding terrain, collecting soil and rock samples to study Mars geology and search for signs of past life. The Perseverance rover and other pre-sent robotic systems will act as their robotic assistants, mapping the area and providing critical data. One of the most important tasks is testing systems that convert Mars's resources into usable materials. The MOXIE experiment will scale up to produce oxygen from the planet's carbon dioxide-rich atmosphere, while Sabatier reactors may create methane fuel for future missions. Living on Mars is not easy. The crew faces constant threats, extreme cold, thin air, and radiation levels far higher than those on Earth. The habitats are designed to shield them, but regular maintenance and monitoring are essential to ensure safety. Every system, from air filtration to power generation, must operate flawlessly in this unforgiving environment. Then there's the human factor, living in close quarters, millions of kilometers from home. Teamwork and psychological resilience will be just as critical as technical expertise. The crew will follow strict schedules, alternating between work, exercise, and rest to stay physically and mentally fit. The first mission is just the beginning. The data collected and systems tested during these 30 days will pave the way for longer stays in the future. Each mission will refine our understanding of what it takes to live on Mars, from expanding habitats to growing food on a larger scale. The ultimate goal is to establish a permanent presence on Mars, a self-sustaining base that can support not just exploration, but the seeds of a Martian colony. With their tasks completed and systems operational, the crew prepares for the next phase, returning to Earth. But the work they've done will lay the groundwork for everything that follows. In the next chapter, we'll explore how the crew makes their way home and the lasting impact of their mission. After weeks of intense exploration and hard work on the Martian surface, the crew is now ready to begin the next critical phase of their mission, the journey back to Earth. But leaving Mars is just as challenging as getting there, requiring careful planning, precision, and a bit of Martian ingenuity. Before liftoff, the crew performs final system checks on the return vehicle, which has been prepped and fueled using resources extracted on Mars. The Sabatier reactors have been converting carbon dioxide from the Martian atmosphere into methane and oxygen fuel, ensuring the spacecraft has everything it needs to launch safely. All critical data, samples, and equipment are securely stowed, ensuring nothing valuable is left behind. The habitat modules and surface equipment remain in place, ready for future missions to build upon what this crew has started. The departure begins with the Mars ascent vehicle firing its engines to lift the crew into orbit. Unlike the dramatic launches from Earth, this one is smaller in scale, thanks to Mars's lower gravity and thinner atmosphere. Still, precision is key. Reaching orbit requires perfect timing and execution. Once in orbit, the crew docks with the Mars transfer vehicle, which has been waiting patiently for their return. This spacecraft, equipped with life support and propulsion systems for the long journey, will carry them back to Earth. The trip back to Earth mirrors the outbound journey, taking about 6 to 9 months. During this time, the crew will face many of the same challenges: radiation exposure, microgravity, and psychological strain. However, the thought of returning home and the monumental achievement they've just completed provides motivation to see it through. On board, the crew will focus on maintaining their health, monitoring the precious Martian samples, and documenting every aspect of their mission for analysis back on Earth. Communication with mission control becomes easier as the distance between Earth and the spacecraft shortens. As the spacecraft nears Earth, it's time for the most perilous part of the return re-entry. The crew transfers to a re-entry capsule designed to withstand the intense heat generated as it plunges through Earth's atmosphere at speeds exceeding 25,000 kilometers per hour. Once the capsule slows down, parachutes deploy, guiding it safely to the designated landing site. Teams on the ground are ready to recover the astronauts and their cargo, bringing them back home to a hero's welcome. The return journey isn't just about bringing the astronauts back, it's about bringing back knowledge. The Martian soil and rock samples, the data from their systems, and the experience of surviving on another planet will shape the future of space exploration. This phase completes the first human mission to Mars, but it's not the end of the story. It's a new beginning, a stepping stone for longer stays, more advanced missions, and eventually permanent settlements on the Red Planet. The journey to Mars is more than just a mission. It's a declaration of humanity's endless curiosity and our unwavering desire to explore. From the first steps on the Moon to the first human footprints on Mars, we've proven time and time again that no frontier is too distant, no challenge too great. This mission isn't just about reaching another planet. It's about learning, adapting, and pushing the boundaries of what we thought was possible. The technologies developed for this journey will not only reshape space exploration, but also solve critical challenges here on Earth, from sustainable energy to advanced recycling systems. But perhaps the most profound impact of this mission is the way it changes how we see ourselves. Looking back at Earth from Mars, humanity becomes a single entity, a species capable of extraordinary things when we work together. Mars is no longer just a red dot in the night sky. It's a new chapter, a new opportunity, and perhaps one day, a new home. And this is only the beginning. With the success of the first mission, the foundation is laid for an era of exploration that extends far beyond Mars. The lessons we learn here will guide us to the outer planets, to moons rich with potential, and maybe even to other star systems. As we wrap up this incredible story of humanity's boldest adventure yet, let's not forget, every great achievement starts with a dream. The dream of Mars is now within our grasp, and the journey there will inspire generations to come to reach even further. Thank you for joining us on this incredible journey. If you're as excited about humanity's future as we are, make sure to subscribe to MindMeld for more deep dives into space exploration and beyond. Until next time, keep looking up, because the stars are just the beginning.